Hello, algebra students. Mr. Lawrence here, and there have been a couple of you that have been absent, so I wanted to make a video to help you with some of this factoring stuff. Today we're going to be factoring trinomials when a is not 1. Now remember, we've got our plan of our attack, right? Our plan of attack, let's see. Our plan of attack said first we got to look for the greatest common factor, right? And secondly, we have to ask ourselves how many terms. Some problems we might factor 2, 3, even 4 times, but how many terms, right? If there's 2 terms, then we try the difference of perfect squares, right? A perfect square minus a perfect square. If it fits, we factor it. If it doesn't, we're done. If it has 3 terms, we know 3 types of factoring. The first one we want to try is the perfect square trinomial, because if it is, we'll be done in just a second or two. If not, we look to see, is a equal to 1? If it is, then we go ahead and factor, right? We list the factors of c. If it's not, then we have to list the factors of a and c, and that's what I'm going to be going over this type of problem today. Now, just to mention, soon when we come back from break, we'll be doing polynomials with 4 terms, and those are actually really easy because they're just GCFing 3 times. But anyway, back to today's topic. Today's topic is factoring trinomials when a is not 1. So let's say we have this trinomial, this quadratic trinomial, 6x squared plus 13x plus 5. Okay? First thing I do is I look for the GCF. Well, the GCF is 1. That doesn't help me. I can't factor it out. It's got 3 terms. It's not a perfect square trinomial. 6 is not a perfect square. Neither is 5. Both of them have to be. So a is not 1. Here's what I need to do. I'm going to list the factors of 6. Make sure I get them all. And list the factors of 5. I'm going to multiply one of the factors of 6 by one of the factors of 5. And I have to multiply their partners. Okay? Then, because the c term is positive, this last term here, I'm going to add the 2 products together. Yeah, so I'm going to take 6, or one of the factors of 6, multiply it by one of the factors of 5, multiply their partners. So if I do 6 times 1, I have to do 1 times 5. If I do 3 times 1, I have to do 2 times 5. And then because the last term, the c term, is positive, I'm going to add. What am I hoping to get? I'm hoping to get positive 13. Positive 13. So let me see. I think if I take 2 times 5, I'm going to get 10. And 3 times 1 is 3. Now, c is positive, so I'm going to add these together. I want to be a positive 13, so both products have to be positive. Positive 3, positive 10 make positive 13. So here's how this factors. It's really easy. I'm going to have 2 quantities. These 2 factors are the x factors. Why? Because they come from the 6x squared. No pun intended there, by the way. So I'm going to have a 2x and a 3x to start each quantity. Now, some of you weren't doing this, and I highly recommend it because it makes your life a lot easier. I want to see a big smile and a little smile. All right, so what did I multiply the 2 by? Well, let's follow this path here. 5, right? And I had to get positive 10. So I'm going to start at the 2 with the big smile, follow it, follow it, follow it. A 5 has to go at the end of that big smile, and it needs to be a positive 5 so that I can get positive 10. 3 got multiplied by 1, positive 1, so I could get positive 3. So this 3x on the little smile gets multiplied by positive 1. And there you go. We just factored a trinomial when a is not 1. A couple things I want to point out to you in case you don't realize it. This last term is positive. The middle term, middle sign, shows up twice. Do you see that? C term was positive, so therefore B's sign showed up in both quantities. Yeah, that'll happen every single time. All right, let's try another one here. Let's try another one. Let me get back in pen mode. And I've got 12x squared minus 32x plus 21. Step 1, look for a greatest common factor other than 1. Fortunately, I'm not finding one. Step 2, it's a polynomial, it's a trinomial. It is not a PST, though, a perfect square trinomial, because 12 and 21 aren't perfect squares. Since a is not 1, I'm going to list the factors of 12. 1 and 12, 2 and 6, 3 and 4. Factors of 21, 1 and 21, 3 and 7. Remember, always list them in order. They'll converge towards the square root of the number. Okay, so now I'm going to multiply the products just like I did in the last problem. I am going to add because this term is positive, and I want to get a negative 32 this time. Tell you what, I'm just going to get a positive 32, and then I'm just going to change things. I think it's easier. So I'm just going to worry about adding to get 32. So let me see if I can look at these numbers and see if I can come up with 32. Let's see, I've got a 28 and 9. No, that'd be 37. That's not going to work. 18 and 14, that'll work. 6 times 3 is going to be 18. And 2 times 7 is going to be 14. And if I add those together, I get 32. The only problem is I want negative 32. Well, I have to add two negatives together. Yeah, negative 18 plus negative 14 would be negative 32. So now I'm ready to factor it. So I'm going to have a 2x to start the first quantity and a 6x to start the second quantity. I do my little smile and my big smile. All right, so the 2 got multiplied by a 7. So I need a 7 here. However, I need negative 14. So it's going to be a negative 7. The 6 got multiplied by a 3, but again, I need negative 18. It's going to be a negative 3. Now, notice what I just pointed out on the last problem. The C term was positive. B's sign showed up twice. 1, 2. There you go. Okay, that's a good check. Let's do one where the C term is not positive. Now, if you've been absent, you might not know. Oh, excuse me. You might not know what I'm talking about with this A term, B term, C term stuff. Well, standard form of a quadratic, and this will just be a quadratic expression. Soon we'll be doing quadratic equations. Will be A times x squared plus bx plus c. Okay, so the next one we're going to do is going to be 8x squared minus 14x minus 15. If I needed to know what A, B, and C were, I could list them out, right? And go A, B, C, easy as 8, negative 14, negative 15, right? A, B, and C, including the signs. Okay, that's going to help us soon. Not in this problem, though. Okay, I've looked for the GCF. It's only 1. Now, it's a trinomial. A is not 1. It's not a perfect square trinomial. So I'm going to list the factors of 8, and I'm going to list the factors of 15. Now, you ladies and gentlemen are so intelligent, I'll bet you can tell me what I'm going to do after I multiply. I'm going to still multiply, one of the factors of 8 by one of the factors of 15 and their partners. But then I'm not going to add. I'm going to subtract. Why am I subtracting? Because the C term is negative. Now I need to subtract to get negative 14. Real easy, if I subtract and get positive 14, I'll just switch the signs, right? 10 minus 7 is 3. 7 minus 10 is negative 3. It's very simple. Okay, so let me see if I can subtract and get 14 here. See, I got 24 minus 5. No, that'd be 19. Ooh, what about 4 times 5 is 20. And 2 times 3 is 6. 20 minus 6 is 14. The only problem is I want a negative 14. So I'm going to do a positive 6 minus 20. And there I go. I have a negative 14. Now I'm ready to factor. So I make my two quantities. The lead terms will be a 2x and a 4x. And I do the big smile and the little smile. 2 got multiplied by 3. The 6 needs to be positive. 4 got multiplied by 5. The 20 needed to be negative. There we go. We just factored. All right. Now, you've learned that certain problems are prime, cannot be factored. For example, x squared plus 36. It looks like the difference of squares, but there is no subtraction in it. This is prime, right? Well, many of the polynomials you'll run into in the real world, yes, you will run into them in the real world if you go into a math field, engineering. These things explain so many things. We'll be doing some application problems in topic 9. Anyway, many of them won't be factorable. It'd be cool if there was a way to tell. Well, there is. It's called checking the discriminant. First of all, you know, in topic 9, you're going to have to learn this lovely song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's called the quadratic formula, and it's going to be your best friend when dealing with quadratics. But for right now, we care about this part right here under the square root. This b squared minus 4ac part. This is called the discriminant. This is called the discriminant. The discriminant. And it can actually tell us a lot of things. Just for today, we're only going to talk about one of the things it tells us. If the discriminant is a perfect square, the expression can be factored. The expression can be factored. If it's not a perfect square, then the expression can't be factored. Let's test it on this one that we already know to be prime. Okay, we've got x squared plus 36. So I'm going to list out a, b, and c. A, b, c. Easy as 1, 0, 36, right? Because there's no x's in there. Don't get fooled by that. Now I'm going to plug those values into b squared minus 4ac. Well, b squared is 0, right? Or b is 0, and I've got to square it. Notice I'm using parentheses when I substitute in. Okay, 4 times 1 times 36. Some of you are going to freak out. I can't do this without a calculator. Quit being wimpy. This is easy stuff. Look, I don't even need to finish multiplying. I will, but I don't need to because I know my product's going to be negative. There's no such thing as a negative perfect square because you can't take a number, multiply it by itself, and get a negative. You can't. A negative times a negative is a positive. Two positives multiplied together give a positive. So I will multiply them together, but I don't have to. I recognize it's not going to be a perfect square. I'm going to get negative 144. Now somebody's getting ready to argue with me and say, wait, 144 is a perfect square. Yeah, but not negative 144. You can't take the square root of it without using the imaginary number system. Some of you know that. Very few, though. You'll learn that probably geometry or algebra 2. So you see, because I did not get a perfect square, this cannot be factored. So I want to give you a trinomial, okay, x squared plus 2x plus 25. And I want you to test the discriminant on it. List out a, b, and c. Do b squared minus 4ac and see if you get a perfect square. Go ahead and pause the video. If you don't, you're just cheating yourself of the opportunity of learning. So here I come with my solution, or my way to do it. If you haven't done it yet, please pause the video. All right, here I go. A, B, C, easy as 1, 2, 25. Okay, so b squared is going to be 2 squared minus 4 times 1 times 25. So 2 squared is 4 minus, oh, I'm just going to simplify that right away. That's 100 over there, right? 4 minus 100. Now, that would be negative 96. Of course, no perfect square is negative. What's the smallest perfect square? Why, 0, of course. 0 times 0. You cannot have a perfect square in the negative number system. Now, please don't assume that whenever you use the discriminant, when it's not factorable, you're going to get a negative. No, you just get a number that's not a perfect square. If I'd done all this work and gotten 12, the trinomial would not be factorable, or the polynomial, I should say. Okay, so this is prime, cannot be factored any further. Okay, there's one more thing I want to show you. It's much in line with what we're doing. I'm going to write down 3x squared plus 13x plus 12. Okay. Hey, Walt, I'm in the middle of recording a video and I can't pause it. You want to say hello?
Hello.
They can't see you. They can only hear
How
you.
you doing?
There's no
Boys and
camera.
Girls Club today?
Yes, sir.
Still having it?
Yep.
Okay.
All right, that was my good friend Walt taking care of business. So let's get back to our business. All right, so first thing I do is look for a GCF other than 1. No, there isn't one. 1 is the GCF. Doesn't help me. Going to list the factors of 3. Going to list the factors of 12. Now I'm going to make a mistake on purpose. Going to make a mistake on purpose. So let me write down 2 and 6. Okay. Now all of a sudden I'm having a hard time finding the right pair of factors. I can't come up with an addition problem that gets me 13. I do 3 times 2 is 6, plus 6 times 1, that's 12. I'm not coming up with 13. So you know what I'm going to do? I'm going to check the discriminant. Watch how useful this can be. Now I know many of you realize, hey, I didn't write down all the factors of 12. But I'm trying to put myself in your shoes and see if you make a mistake, give you a strategy of how to work your way out of it. Because that's the key to life. Nobody's there to bail you out. You need to learn to work your way out of situations. All right. So I set up the discriminant and I get a 169 minus 144. Well, that's going to be 25, right? 25 is a perfect square. I know this expression can be factored. So therefore, I'm going to go look, and sure enough, I forgot to write down 3 and 4. Okay? I'd like you to finish factoring this problem. Go ahead and pause the video, finish factoring. I'll show you my solution here in a second. Here comes my solution. All right, 3x plus 4 in one quantity and x plus 3 in the other. All right, that's it for the video. Please email me if you have any questions on it. Mr. Lawrence signing off. Have a good night, everybody.